Yeah. So IOSight is a software solution provider. We provide data analytics solutions for the water and energy industries for over a decade. We have over 100 installations. We are expanding to global markets. We started back in 2008 with the Israeli market, but expanded during the last 7 or 8 years. We expanded to primarily to the US, but we have few installations in China and few in Brazil, Cyprus, Italy, and now we are looking to explore those opportunities in India. So as said, our customer base is diverse. We have water and wastewater treatment facilities. We have desalination plants, supply and distribution systems, municipal or public or private, and watersheds. When it comes to watershed, we have a specific solution that will elaborate a little bit more than on the others, because I understand that there's a great relevance to that item. So a bit about our solution. iGreen is our core solution suite. It's a software solution that is comprised of 4 elements: the data foundation, the outputs, the reporting, the event management and task management, and the advanced analytics. Data foundation means that we can collect data from practically everything. We cleanse the data, we arrange the data, we store it, model it. That's the first layer, which is significant. The second layer is the presentation of the data, displays which are usually used by mobile phones and by web interface. We have dashboarding tool that is configurable. Our customers are creating their own dashboards, and a pretty advanced reporting tool. And that is a major part of the use of our customers is focused on that. The third and the fourth are the event management and task management. So we have sets of modules that are surrounding or complementing our dashboarding and reporting system. So we have an event management system, we have a task management and preventive maintenance module. We have a sampling planner or schedule and sampling management, and then a lab module, a laboratory management module. And the fourth layer, which is the most important one, is the advanced analytic. And again, it is comprised of 2 elements. First, it's a configurable tool where each of our customers can tailor-made his own algorithms. And second, sets of off-the-shelf solutions, and we have 4 of them that already has the algorithm and the displays and the application embedded in that. So data foundation, insightful outputs, advanced analytics, and event task management and other surrounding modules. Let's go one by one, and then I'll go back to the iShed to elaborate a little bit more, and I'll show you some real-time screens. So the iShed is a water quality monitoring platform designated to detect pollutions, contaminations in rivers and lakes. It's a specific algorithm that detects the anomaly and more importantly, eliminates false positive, because, so you know, the main enemy of those event systems and the detection system is that they have too many false positives. Whenever a pH reaches a certain limit, you will see an event, but that doesn't mean that it's a real event. That means that for some reason there's an exception, but it might be a muddy area or a kayak that is taking out mud from the creek, and create a turbidity issue, and there are many other examples of false positives. So the algorithm eliminates those, and once we are sure that we have a contamination event, we calculate the downstream propagation, meaning the speed of travel, so we can indicate how much time it will pass till the contamination will reach the next station or the next point. The system is used by the city of Chicago, covers the entire northern watershed of Israel, the Jordan River and the Sea of Galilee, cover a few sites in the US with working with American Water, and this is part of what we intend to do with the Clean Ganges project. We have another 2 projects in Brazil that are focused on that. The iDetect is an early fault detection engine designated to detect anomalies related to pumps and motors, and make sure that we find out or detect those issues of pumps before a breakdown occurs. That means that we can indicate that something goes wrong. You go out to the field and check the pump, and then you see that there's a lugger that is shaking, or there's an oil leak, or any indication like that. And then you can replace the lugger for $400 instead of waiting another month and then being forced to replace the entire pump for hundreds of thousands of dollars. So that's the concept of the iDetect. The IWT is an optimization tool for water and wastewater treatment facilities. It recommends in real time on the best performance mode in terms of energy and chemicals, and it contributes to cutting down costs, primarily chemical and energy, but others too, maintenance-related and equipment-related costs that are also very important in certain facilities. Last but not least is the iNet. It's a non-revenue water solution for DMAs, district metered areas, and it calculates in real time the actual losses that you have on each of those district metered area neighborhood, and indicate whether there's a major change on the status of this of the DMA, which means that it's probably a new burst or a new leak, or an anomaly that should be checked. In some cases, we find out that the water loss, the normal water loss, the standard water loss can be, but now you have 15. That means that something is wrong, even though it looks like the situation, but it means that something is wrong with either with the meters or with the way we calculate. So to conclude, platform, and that's very interesting and that's very important when it comes to working with public and private utilities and with authorities. The difference between a success and a failure of implementing digital solution is in some cases can be very narrow, very tight, and it depends on the quality of the solution. So in order to succeed in a project, you need to have a good will from the customer. You need to have a strong need. So anything from regulators compliance to operational needs, technical billing or invoicing or metering need. So that is very important to have the need. Minimal constraints or minimal prerequisites. So if you don't have any data sources or any monitoring stations or any SCADA in place, then we have a problem, and then it might be a burden that will prevent us from the goals that we set up. And last is the quality of the solution that is chosen. And on that aspect, we feel very proud. We've been working on that for 15 years, so we are lucky to have this level of readiness and level of maturity just on the right timing for marketing. And now it's the time in India and in the US and in Europe. Now is the time that utilities are ready to adopt digital solutions. So ease of use and scalability, algorithm development functionality, quality outputs and displays, cost of setup and deployment, or limited cost of setup of and deployment, security, cyber and computer and network security, and we support that. Data modeling and normalization, multi-layer data integration and synchronization and connectivity, and above all, the project management or the methodology of implementation. Those are very important aspects of a successful project. This is a project, an implementation that we have done recently with a company, a big company called American Water in the US. They have plenty, 73 water treatment plants. So each water treatment plant has an intake that in most of the cases pumps its water from a river or from a lake. The goal is to analyze the quality of the water and provide them with an early fault detection of faults, which means shut down the facility and test the quality of the water, because otherwise it will create a huge damage to the treatment facility. And moreover, if, and that was the case, there's a famous case in 2014, moreover, it can get into the pipelines, and then the residents will open the taps and see black water. And it happened in West Virginia in 2014. So that's the reason why they hire us to do this very interesting project. So they have a control. The result is that they have a control room with covering the entire picture, their entire. We are not in 73, we are in about 10 right now, but we cover a pretty wide area. And so whenever they see on the map a red icon, they can go down and drill each and every one of those stations. So you can see here in May, there was the index showed that there was an event. In this case specific, it was a flood that brought a lot of turbidity and the TOC increase. And so what we do is we create an AI-based index that shows them good or bad, green or red, and that is based on statistics or mathematics, and it is based on integrating the entire sensoring or the entire parameters that they have there into one accumulative index. Usually there are 4 or 5 parameters that are monitored in terms of quality of river. So pH, turbidity, conductivity, DO, in some cases redox as well, and in some cases like this one, TOC. So they have this index, they see it on the map, and then they can drill down on the status, which of the parameters is now transmitting data, what are the scales or what are the weights of each parameter, and they can go down and drill on a specific trend and see, how it reacts to a specific case. The outcome of that is that number one, they have an indication on the map. Number two, they have an event management system that they can see. So here I don't have any event, but they can see a list of events that are active, and then they have a to-do list that they can drill down and write down and understand what are the action items, and they can type in what have they done or what is the status of the event. In many cases, the events are treated, so they shut down the pump, the intake pump, they wait for instruction, but the qualities of or the status of the water remains problematic because the nature of those events is that the water is not getting cleansed in a matter of half hour. Those are events that can last days in some cases. So you have the status from one end, you have the status of the water, and from the other end, you have the acknowledgement or the way you reacted to the plan. So it's quite a neat, quite a comprehensive platform. Another example that I wanted to show that is not the iDetect, it's a typical water utility in the West Coast. They have multiple dashboards that are covering their entire business, from potable water to water and wastewater treatment plant, from reclaimed water network, purple lines, to pure water facility. They can drill down and up. They have multiple regulatory reports that are sent automatically to the regulators on a daily, weekly, monthly basis. They are now implementing our iDetect for pump health monitoring, and we are now exploring a very interesting project to integrate meter data management, online meters, AMI system that they install together with the SCADA data, and provide them with balances and indications on number one, the water loss situation, and also on what they call the aging storage of water, because one of their concerns is that when consumption is reduced during winter time, and in some cases during summertime when there's a water scarcity, they are very sensitive to the age of the water within the pipes. They don't want water to lean in the pipes, to lie in the pipe for too long because they might be polluted. So that's a very important, a very interesting project, and we have multiple indications that are related to that. So with that, I think we covered most of what we wanted, and I leave you with the Q&A and open discussion.